Next is catalytic properties of transition metals. Already from Unit 7, we know what is the meaning of catalyst. Catalyst is a substance that can alter the rate of the reaction, but they never participate in the reaction. Basically, all the transition elements are frequently used as a catalyst because of they have unpaired d electrons and they have energetically available d orbitals. With the use of that empty d orbitals, d block elements can make a new bond with reactant molecule. For example, consider a scandium atomic number 21. Electronic configuration, outer electronic configuration 4s2 3d1. d orbital has 5 orientation. But in d orbital, scandium has only 1 electron. So remaining, it has 4 empty orbitals. With the use of this empty orbital, the scandium can make a new bond with reactant molecule, and it makes the reactant molecule active to give product easily. After getting the product, the scandium is leaving out from the product. In your book, for prove the catalytic properties of d block elements, they were given some examples. That is, preparation of alkane from alkene, then Ziegler-Natta catalyst of polymerization. Some more examples also given. These all you learned in 11th standard. Next is alloy formation. Alloy formation. What is alloy? Alloy is a mixture of two or more metals. Otherwise, alloy is the mixture of two metals. In this, which metal is high in percentage? Which metal is present high in percentage? That is termed as solvent. Which metal is low in percentage? That is termed as solute. So alloy is a mixture of two or more metals. Which metal is present in more amount? That is known as solvent. Which is present in less amount? That is known as solute. Why transition metals form alloys? That is because of the d block elements. Transition metals are similar in their atomic size. And one metal atom can be easily replaced by another metal atom. Because of these two conditions only, all the transition metals form alloys. In this, Hume rule 3 says one rule. If the metals obey this rule, that metal can form the alloys. What are the points he predicted? First one, the difference between the atomic radii of solvent and solute is less than 15%. Second one, Both the solvent and solute must have the same crystal structure and valence. Third one, their electronegativity difference must be close to 0. These 3 points only Hume-Rothery rule. Next is interstial compounds. Already from Unit 7, Unit 6 we come to know what is interstial compound. If the metals are arranged like that, in the metal atoms are arranged like that, it has some gap. These gaps are known as interstial holes. These holes can occupied by small atoms. This hole can occupied by small atoms like carbon, hydrogen, boron. This compound is known as interstial compound. An interstial compound or alloy is a compound that is formed when small atoms like hydrogen, carbon and boron are trapped in the interstial holes in the metal lattice. Example, TiC, titanium carbide, then zirconium hydride, etc. These interstial compound has special properties. They are very hard comparing to pure metals. Then they have high thermal conductivity. They have high melting point comparing to the pure metals. Transition metal hydrides are used as a powerful reducing agents. Metallic carbides are chemically inert. Next is a formation of complexes. Transition metal ions are small and highly charged, and they have vacant low energy orbitals to accept electron pair donated by other groups. Because of these three conditions, transition elements can make a complex. Next is one general topic. Maximum all of the D block elements are colored. D block elements are colored. Here also, if the elements has unpaired electron, they are colored. That point you have to remind, that is, if the metal has unpaired electron, they are colored. If they don't have electron in d orbital, either they don't have unpaired electron, they are colorless. So if the metal or transition element want to be color, means they must have unpaired electrons. Unpaired electrons. If they are colorless, they don't have unpaired electrons. They don't have unpaired electrons. Otherwise, they don't have electrons in d orbital. So if the elements are colored, they must have unpaired electrons. If they are colorless, they don't have unpaired electrons or no electrons in d orbital. This is a very important note you have to remind. For example, now copper 2 plus is colored. Copper 2 plus is colored. Proof this they are asking. Copper atomic number, what is this? 29. Electronic configuration 3D10 4s1. Here they ask about copper 2 plus. That means we have to remove 2 electrons. We have to remove 2 electrons. So one from s orbital, one from d orbital. So it's converted as 3d9. That means it has one unpaired electron. One, two, three, four, 5, 6, 7, 8, 9. It has one unpaired electron. So copper 2 plus is colored. On the other hand, zinc 2 plus. Zinc 2 plus is colorless. Zinc 2 plus is colorless. Why? If they ask like that, surely you have to find the electronic configuration. Then Z10 atomic number is 30. Electronic configuration, zinc electronic configuration 3D10 4s2. Here they ask about zinc 2 plus. 2 plus means we are going to remove the 2 electron from here. So we are going to remove the 2 electron from 4s only. So zinc 2 plus electronic configuration is 3D10. Now we are going to find the unpaired electrons. Either it has unpaired electron or not. 10 electron it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here 5 boxes also has paired electron only. That means there is no unpaired electron. So there is no unpaired electron. So zinc 2 plus is a colorless. If they ask any questions, this is a colored compound or colorless compound, first your answer is, you have to give the electronic configuration of given compound, and then there is no unpaired electrons, there is no possibility of DD transaction or DD transition. Once again I recall today's class. Today we learned catalytic properties of D block elements, magnetic properties of D block elements, alloy formation, interstial compound formation, and then complex formation. At last we learned how to find the colored compound and colorless compound, why the compounds are colored. Thank you, students.